Hello, in this video we will be creating a GCC cross compiler. If you are on Linux, you can skip ahead to the next step as this step is for Windows users only. Alright, so we need to go into the Microsoft Store and search for WSL, which is the Windows subsystem for Linux. This will allow us to run Linux commands on our Windows installation. We want to choose the Ubuntu version and install that. And then when that's done downloading, we need to go to the search bar and type turn Windows features on or off. And in this little dialog box, we need to scroll down to the bottom and make sure Windows subsystem for Linux is ticked. If it is not, then tick it and then restart your system. Now that Ubuntu is installed, we've ticked Windows subsystem for Linux and restarted our computer. We can now go down to the search bar and search for Ubuntu. And we'll just run that and let it set itself up. When that's done, we can start running commands and getting our build system operational. Alright, now we need to set up our Unix username and password. I'll just be Poncho and my password will be a secret. Alright, now that we're set up, we just need to do sudo apt update just to make sure we are up to the latest version. We just run that and put in our password. Alright, so we put in our password and let it update to the latest version. Okay, now that we've upgraded, we can start downloading the packages we need to compile our compiler. So we need to do sudo apt install build-essential. There we go, sudo apt install build-essential. Now essential has an E, right. So we'll just do that, and yes, we want to continue. Okay, now that that's done, we can move on to the next step, which is sudo apt install bison. Yes. Now we must do sudo apt install flex. Yes. Now we need to do sudo apt install libgmp3-dev. Yes. Now we need to do sudo apt install libmpc-dev. Yes. Now we need to do sudo apt install libmpfr-dev. Now we need to do sudo apt install texinfo. Yes. Okay, now we can start actually building. So we need to do export prefix, all capitals, equals, quotation mark, /usr, /local, /x86 _ 64 elf GCC. Now we need to do export target, all capitals, equals x86 _ 64 elf. Now we need to do export path equals quotation mark $ prefix, all capitals, /bin $path, all capitals. Now we must do make dir /tmp /src. Now cd /tmp /src curl hyphen big O http //ftp.gnu.org /gnu /bin utils /bin utils -2.35.1 This one might take a little bit of time. Alright, so now the next step is to type tar. So we'll extract the tar file that we downloaded, xf bin utils -2.35.1.tar.gz. Okay, now that that's done, we need to make a new directory, so make dir bin utils -build we'll cd into that directory, so cd bin utils build. Now we will type ... / this is going to be a long one, so ... bin utils dash 2.35.1 / configure space -- target equals $target -- enable interwork -- enable multilib. I'll just expand this so that it's easier to see. -- disable -nls - disable -w error -- prefix equals $ prefix capital 2 greater than and 1, or so that's the vertical line if you hold shift and backslash TEE configure .log, and this will just configure our bin utils installation. Okay, now that that's done, we need to do sudo make all install 2 greater than and 1 or t make.log. This process takes a bit of time. Alright, now we have done making bin utils. Nice. Now we can start building GCC. So we need to cd back to / tmp and / source. And we need to download the GCC files. So curl -o big O https / ftp.gnu.org, so ftp.gnu.org / gnu / gcc / gcc -10.2.0 / gcc -10.2.0.tar.gz. And this is going to take a little bit to download as well. Alright, now that we've downloaded that, we need to extract it just by doing tar xf gcc -10.2.0.tar.gz. Sorry, I did 20 and not 2. Here we go. So tar xf gcc -10.2.0.tar.gz. Just let that do its thing. It might take a while. Alright, now that that's done, we need to make directory. Make dir gcc-build. And we need to cd into that directory. So cd gcc-build. Now, this is a big one. So .. gcc-10.2.0 / configure space -- target equals $target space -- prefix equals $ prefix space -- disable -nls space -- disable -lib ssp. Now we'll do space -- enable -languages equals, and we'll be using C++, so equals C++ -- without -headers. And we'll just run that and see what it does. Alright, so now we need to do sudo make all -gcc and enter your password. Now this is going to take quite some time, so I would recommend going off, making a coffee or whatever you drink and doing something else, coming back when it's done. Alright, so now that we're done with that command, we can run the next one. Sudo make all -target -lib gcc. And this is going to take quite some time as well. Alright, so that was very quick. So next one, sudo make install -gcc. So we have sudo make install gcc. Alright, we have last but not least, sudo make install -target -lib gcc. Right, now we can do ls space /usr /local /x86_64 elf gcc /bin. And we can see that all of our binaries have been created. This is exactly what we want. So we have our compilers, so we have elf-gcc, elf-g++, and we also have our linker-elf-ld. We have successfully built bin-utils and GCC, and now we have our GCC cross compiler. Hooray! Now the last thing we need to do is add our binaries to our system path so we can use them from anywhere without having to cd into this directory. Alright, let's get started. So sudo nano ~/.bash rc. Type in your password. Right, now we need to down arrow all the way to the bottom of this file. We need to add a new line. So export path equals quotation mark $path colon /usr /local x8664 elf gcc /bin quotation mark. Now we can do Control X and then Y to save, and then just press enter. Now we need to restart. So if you're on Linux, restart your computer. If you're using WSL, just close and reload your Ubuntu WSL. Now we should be able to do x86_64-elf.gcc, and here we go. Fatal error, no input files. Right, so that's fine and dandy for Linux users. That will be how you compile and link your files. Similarly, for the linker, we can do x86_64 elf-ld, and we have no input files, so that's working fine. But for Windows users, it's going to be a little bit more complicated. We need to open up the search bar and type in environment variables, and then in this window here, we just click on environment variables. We want to create a new variable, and we want to call it WSLENV, and the value wants to be /usr /local /x86_64 elf-gcc /bin. Alright, now in command prompt, we will be able to do WSL $WSLENV /x86_64 elf-gcc. And here we are running it inside command prompt. Now, the following videos are all done in Windows, and they were using a Cygwin installation, so we didn't have to prefix all of the commands with WSL, $WSL, etc. But if you followed this tutorial to build your GCC, then you are going to have to prefix every GCC command in Windows with this WSL, $, etc. Now we can get on to writing some C code. So we'll add a new item. We'll call it kernel.cpp. Now let's make a simple function. We'll call it void_start. Return. Now in order to link to this from our assembly code, we're going to need to declare this as extern C. I don't know why it can't link to C++ code, but it links to C code perfectly fine. The next thing we need to do is go into extended program and remove our origin, because our link is going to do that for us. And we need to declare extern start, and now we can do jump start, or rather call start. So now we'll get to here. We're declaring external so that our linker knows to find this function and put it here, and then we'll enter this code here. Now we need to move on to changing our compiler options so that we can compile it with our new C code. So this is what we had last time. To compile our new CPP and link it properly, we're going to need to do a few things. We need to change this to the ELF64 format and change this to something else just so that we know it's not a binary. And then x8664 ELF GCC to use our compiler. Freestanding no red zone M64. Now we can give it our kernel.cpp file, and our output can be kernel.o. Now we can link our extended program and our kernel.cpp together. Custom LD to use the one that we just created. Output kernel.temp for a temporary file. Capital T text, and then our origin, so 7E00, the same as what we were using before. Extended program.o and kernel.o. So that'll link extended program and kernel.o and output it into kernel.temp. Now we can object copy the values of kernel.temp into kernel.bin. So our output is binary, capital O, by the way, very important. Kernel.temp into kernel.bin. Now we need to change extended program.bin to kernel.bin. Right. Now let's see if this works. There we go. So we've made our assembly, we've compiled our C code, we've linked it, we've copied it, and we have our new kernel code. Now if we run it, we should have nothing changed because we haven't actually added any new code. Now, just to validate that we are actually running this C code, let's do something special. Let's make a int pointer to B8000, which is our video memory address. And then we can do something like this. And we'll see what that does. As you can see, it's put PP onto our screen and has changed the color formatting because we are setting the bytes in the video memory to this value. And now we have successfully made our GCC cross compiler and used it to compile some C code. Yay! That will be it for this video. Maybe in the next video we'll be doing something a little bit more useful. But for now, thanks for watching, and I'll see you next time.